Okay, welcome to another part of Ars Electronica home delivery. Today, as you may notice, it is in English, and today's part we're going to do is the program UniView. We were experiencing some technical problems with the sound. That's why we are a little late for the live stream. But yeah, if you're not watching it live, it won't matter to you. So, UniView, it's already started in the background, is one of the favorite programs we have in Deep Space, our special presentation room. Normally, it's a 3D program, but that won't work over the internet. Normally, people are sitting here on the floor and are experiencing the whole event in 3D with glasses on. But we switched it to 2D, and I'm going to give you an overview about the options we have in the UniView program, which is a real-time animation, and I'm operating it with this Android phone. If I move my finger over the screen, I can turn things around. If I flip it, I can zoom out or zoom in. And as you might already notice, there are some options in this program which you normally don't see. In the background, the red line would be the orbit of the moon, which is naturally not visible in the night sky. The whole program, as I said, is a real-time animation, and so the thing called Terminator, that's the line between light and darkness here, is exactly where it is right now. And if I go outside and it's starting to get dark over Europe in the program, I'll notice twilight outside. This also changes with the season. So this is what they call a real-time animation. And that's not only the case on the Earth, but also on all the planets and their moons. The moons are moving around the planets, and they are situated exactly as they are. And also the shadow, but darkness and light on the planets is as it would be in real life right now. It's assembled out of images of satellites and several different probes. And you can also see some things which you normally don't see. For example, this is a phenomenon which unfortunately most people don't know. This is the so-called light pollution. You can see all the bigger cities, the coastlines. The problem that if an alien would fly by, that they might recognize that this planet is inhabited is not, is more like zero, but most animals think this light in the darkness is the moon, and so scientists think that 1/3 of the insects worldwide are victims to light pollution. Another thing I should point out in the background, this is a light unpolluted night sky. If you would turn off all the lights in the darkness, that's what you would see. And at the moment, we are also in the center of our Milky Way galaxy. This is the so-called Pipe Nebula, and over here would be the center of our Milky Way, which is 26,000 light years away from us. I already told you we can show some features which are normally not visible. Here you have the orbit of the moon again, and then I can turn on something, and normally if people are in here, then I ask them what they think they are seeing, and most of the time I immediately get the reaction, the Earth's magnetic field. Even so, most people know that the Earth has a magnetic field. Not everyone is aware that it has this odd shape, kind of like a tail. And the reason why it's shaped like that, I can turn it in, it's moving away from the sun. like a comet's tail, and the reason is the same. It's the so-called solar wind, electromagnetically charged particles which come from the sun. It takes light 8.5 minutes to go this distance. It takes those particles up to some days, and then some of them are caught by the magnetic field and circle down on the poles and cause something which we know as the polar lights. So we are doing a tour through this, and with this Android phone, I can also beam me around. I can, for example, beam myself to Mars. And we landed on the night side of Mars, but I can turn it around. So if you would have a telescope pointed at Mars, that would be exactly the light and darkness distribution on Mars right now. And unfortunately, we are in there at the boring time. And here you see Valles Marineris, but the Olympus Mons, the highest mountain of the solar system, is hidden in darkness. Then we can go on with our tour and go and jump to Jupiter and Jupiter's moons. And you can see the old moons, the Galilean moons, Io, Europa, Ganymede, and Callisto are moving around the planet's equator, and the rest of the moons, I sometimes think it looks more like a bird's nest. Those were mostly asteroids which were caught by Jupiter's gravity. We can also beam ourselves to Saturn. It takes probes months or years to reach that fifth planet from the sun. And that is the last planet which you can see with the naked eye. And even the ancient Greeks knew about Saturn. Normally, when people are sitting on the floor in here, then we have them sitting on Saturn's rings, because the Ars Electronica Center in Linz is one of two places in the world where you can experience sitting on Saturn's rings. Okay, so we zoom out and look at all the orbits of the planets in a second. So here we go. In green are the orbits of the planets. In there Mercury, Venus, Earth, and Mars. Then in the asteroid belt there is the dwarf planet Ceres. Then we have Jupiter, Saturn, Uranus, and Neptune. And this would be the orbit of Pluto. And if you look at all the orbits of the planets from the side, you see that Pluto doesn't really fit in. As I said, we can turn things on and off in this program. And so, for example, I can make the constellations visible. When I'm here with an audience, then I usually ask them, do you think that the night sky looks different if you are outside the orbit of Pluto? And then I have them guess. And some guess that it looks the same, which I can prove to them by showing them the constellations. Here we would have Sagittarius. Here we have Corona Borealis. Then over here is something almost everyone notices. It's the Big Bear in German, the Big Dipper in America, and the astronomical term would be Ursa Major. And with this, you can also explain why the night sky looks exactly the same, because the distance between Pluto and the Earth is on average around 6 hours. The stars in the Big Dipper or Ursa Major are around 100 years away. And as 6 hours don't matter with time in 100 years, it's the same with the distance. 6 light hours don't matter with 100 light years. We can prove that by moving out. And when we are around 50 to 70 light years away, then you suddenly notice that the night sky starts to distort, and our stars are not fixed on a globe. Some are farther away and some are closer to us. And here is Proxima Centauri, a part of the Alpha Centauri star system. It's 4.2 light years away, and it would take a rocket several decades to reach it. It has an exoplanet, because this is the next thing I'm going to show you. We can mark stars which we know are orbited by exoplanets. Everything which is pointed out in blue now are stars which have exoplanets. When this program was done several years ago, there were a few hundred known exoplanets. The momentary count is over 4,000, which means that obviously planetary system complete normal with the formation of stars, and even double and triple star systems seem to have planets normally. We now use this kind of the constellations as a pointer, because we zoom out and look at all of our Milky Way. This is a fake image. Nothing has left our Milky Way and sent an image back. The probes, which are the Voyager and Pioneers, which are on their way for about 40 years, are barely at the edge of our solar system, and nothing has yet left the Milky Way. We are not even absolutely positive if our Milky Way has 2 or 4 spiral arms, because we cannot look through in the center of the Milky Way. And I mentioned the supermassive black hole in the center of the galaxy earlier. Okay, she's saying a black hole, and then we see a lot of light. This is heated gas, which is close to the center of our Milky Way. Maybe every dot around us is a galaxy. And those, for example, here you can see, those are the 2 Magellanic Clouds. So you already notice that images are above those dots. And I'm moving around a little bit. And let's see if I can find Andromeda, and here it is. This would be Andromeda and the Triangulum Nebula, and if you don't believe me, I have the possibility to show the galaxy labels, and then you'll see M31 and M33 for the Triangulum Nebula. We are too far away, it's not showing. And now comes the highlight, because as I said, the images are already in there, but they are too small to be visible very well, so I can make those images bigger. And whenever people are in here now, they go, because this is quite fascinating. And if you ever get the chance to come to Linz, please come visit us, because sitting in here and getting this experience of moving around the galaxy is really something special, and it's very impressive to our visitors. So now we have all those images of the galaxies in there. They are on the right place, but they are much too big. And if we zoom out, we then reach a place where there are no images. Each dot you see is a galaxy. And if I move that around a little bit, you can see this sand clock shape. Here are probably just as many galaxies as here or here, but our Milky Way is blocking the sight, and so all you see are the galaxies we know for sure. There are at least 200 billion galaxies, and as I already mentioned, it seems that most of those stars, billions of stars in each galaxy, seem to have planets. With the famous physicist Carl Sagan was asked if he thinks there is life somewhere out there. He answered, if not, it would be a terrible waste of space. And I agree with him. So, and the very last thing we can show in this program is the so-called microwave background radiation. A part of the snowstorm on your TV screen, if you have no program set up, is a part of this microwave background radiation, and it proves that our universe was born in a Big Bang 13.8 billion years ago, and the different colors in here are different temperatures. There's only a variation of hundredths of a degree, and where there's red, more mass originated. So this is kind of the baby picture of the universe. So in the red parts, there were galaxies born afterwards, and in the blue parts, there was more than nothing. And we are outside of this now, and scientists think outside this, there's neither neither space nor time. So this is only a tiny part of this program. We could also show the orbit of the sun in the Milky Way, or supernova remnants. In German, we are doing a journey through the universe, and we are reaching part 3 next Thursday at 1 o'clock, and part 4 on Friday at 1 o'clock. The topic on Thursday will be the possibilities of life in our solar system and the universe. And I'm not yet sure what I'm going to do next Friday. You could leave suggestions what you are interested in the comments. And we often end this program like that. The orbit of the moon, 1.3 light seconds, is the only distance humans have really traveled. So if you ever read in a newspaper that maybe humans conquered the universe, in reality they didn't get very far. And our blue marble is like a present. It's the only planet where we know for sure that life exists. And so to end this program, I might advise you, maybe it would be best if we take better care of our home planet, because it's the only place where we can exist. So thank you for your attention. I hope you got an idea what is possible with this UniView program. And maybe one day you'll visit us in here to experience the whole thing in 3D. And I can tell you it's one of our favorites among our visitors. Thank you, and bye-bye. See you next week.